Okay, so let's take a look at the second equation. So the second equation, we are taking a look at an aqueous solution of barium nitrate. So barium, Ba, nitrate, and we said that it was an aqueous solution, so I'm going to put a little AQ here. And sodium carbonate is going to form, so there's our yield symbol, barium carbonate and it's our plus sign, aqueous sodium nitrate. Sodium nitrate. We'll have to barely squeeze this in, so bear with me. Still get the little aqueous symbol down below here, AQ. All right, so there's our skeleton of the problem. Now let's just go back. Let's double check, okay, to make sure that we are writing in all of the charges. So let's check out barium. Barium is a +2 if we look at the ionic charge for barium. So +2, +2. Sodium is a +1. So +1, +1. Nitrate is a -1. And our carbonate is a -2. Okay, so by looking at this, we now have to go, we are going to need to cross multiply here. Sorry, not cross multiply, crisscross. We don't have to worry about the 1, but we do have to worry about the 2. So the nitrate on this side, we're going to put it in parentheses, and we're going to squeeze a 2 in right there. And our sodium, we are going to also have here crisscross. So our sodium is going to have a 2 in that spot. Now, that's for the reactant side. Let's take a look at the product side. We have a 2 and a 2. They crisscross, they cancel one another out. Over here, we have a 1 and a 1. They crisscross and also cancel one another out. So we're good right now with our formulas. So now what we're going to do is we are going to list, we're going to do our atomic inventory. We're going to go ahead and put barium. Barium on this side, we have 1 barium. Over here, we have 1 barium. Nitrate, now, it's a polyatomic ion. And we notice that we have nitrate on this side of the equation as well as nitrate on this side. So let's keep it all together. Let's not separate the nitrogen and the oxygen. Let's keep it all as a group. Now, if we look here, remember, we have the 2 that's on the outside of the parentheses. So on the reactant side, we have 2 nitrates, but over on the product side, we only have 1 nitrate. Okay, sodium. On the reactant side, we have 2. And over here on the product side, we only have 1. And now we have our carbonate. And our carbonate, again, we're going to keep this as a polyatomic ion because it's on both sides of the equation. Over here, we see that we have 1 carbonate and 1 carbonate also on the product side. All right, so as long as we keep the nitrate together and the carbonate together as a group because they both appear on opposite sides of the equation, then that makes it a lot easier. Otherwise, we got to count every single one of these oxygens as separate, and that's going to be a lot of oxygens to count. So let's not worry about that. Let's keep them as a polyatomic ion. All right. So our bariums are good. Our nitrate, our sodium are the numbers that are off. Our carbonate's good. So we need to change our nitrate and our sodium right here to 2 so that it equals. So we're going to plug a 2 in as a coefficient over on the product side where it has sodium nitrate. In doing so, this 2 is going to be distributed times the 1 for sodium. So 2 times 1 will give us 2. And now for our nitrate, the 2 will now be distributed to the entire nitrate molecule ion, and we get 2 there. Okay, now if we look, carbonate's balanced, sodium's balanced, nitrate's balanced, barium's balanced. We now have a completely balanced equation. So let's go ahead, and we need to still plug in the 1s for coefficients. And let's also go ahead and do the ratio up on top. So we have a 1-to-1 ratio, meaning 1 barium nitrate to 1 sodium carbonate is going to yield a 1-to-2 ratio, a 1 barium carbonate to 2 sodium nitrates. So that is our ratio, okay, with this as well. Now, let's go ahead and also look at, we got to figure out the second part of the question, and it asks what type of a reaction is this. So we're going to say that barium is A, and we have barium as A. We have nitrate as B, and over here in the product side, it's way over there. And we have our sodium, C, and our carbonate. And so what we end up seeing here is that our cations, our positive ions, our A and our C are going to stay in the same spot, A and C. All right, we have an A, B plus CD. On this side, we have AD plus CB. So really the only thing that has changed is right here, the D and the B have switched places. And we see that over here on the product side. So for the reactants, this is our initial reactants. This is what we get. But once we actually do the reaction, we end up seeing that B and D have switched places. So we have 2 things that have switched places. And since we have 2 things that have switched places, we call this a double replacement. And that is the type of a reaction that we have. So you can see with one simple little question, we can do a lot of different things. And by the way, there are many other things that we can still do with this, and hopefully we will see that later on.